go lower than that, especially.
Sorry?
I don't want to go lower than that.
Yeah, understood. Yeah. Roger.
Yeah.
Yep, yep.
Yeah.
So would y'all mind if I gave a kind of a synopsis of why we're here digging this hole and a little backstory and such?
That'd be
Sounds
grand.
good.
Okay, so this is for those of y'all listening in on the Nautilus Live website, wondering why we're digging a hole here. The reason we're here is to look for a meteorite. In March of 2018, there was a meteorite fall at this site. It fell entirely in the ocean. We're in the Olympic Coast National Marine Sanctuary, just off the coast of Washington State, the West Coast. And I see you have a crab.
Crab's back.
Crab has little sense of self-preservation.
Kim, would you mind actually recycling the dredge again?
Go ahead, Mark.
Yep, sorry to interrupt.
No, it's fine. I don't want to talk over y'all while you're working. Meteorite fall occurred in 2018. It was seen by people as far east as Seattle and heard by people along the coast. It was moving east to west. It ended up over the ocean. We can see signatures of this meteorite fall on a variety of instruments, to include weather radar. Weather radars were not designed to find meteorite falls, but it turns out they work really well for it because they're designed to find falling things like rain and sleet and snow, and meteorites also fall. So the weather radars don't generally detect the bright meteor itself, but if the meteorites actually fall to the ground from a large enough event, then they come down through the measurement volume of the radars, and the radars have a chance of picking these things up. For this event, it showed up clear as day. This was a sizable meteorite fall, and it also showed up on seismometers around the Olympic Peninsula. It showed up on a few seafloor seismometers, which I think might be a first. It was a sizable event. It was a loud event. This thing had produced meteorites which were still moving quite fast, quite low into the atmosphere. Unfortunately, the whole thing happened into the ocean, and so made it a little more difficult to try to get material. A few months after the event, the Nautilus came here to the stream field and collected a series of samples, made a long transect, a long straight passage along the seafloor. We didn't know quite what to expect. We're hoping to be able to spot meteorites on the seafloor. And as you can see, the hole that's being dug here now, this is just really muddy, really fine, silty stuff. And any meteorites that came down here would have just buried themselves in the material. So we didn't see any large meteorites, but I did collect a set of samples from the seafloor, a set of this sediment, and spent about the next year just patiently going through this sediment, this sandy material, until I found little melted bits of meteorite. We found about 150 of them, and of those 150, the majority, about 70% of all those little samples, came from this spot here. This was the site of a circular pit in the seafloor. It was about 60 to 80 centimeters across, depending on how you want to measure it. And it could have, at the time, we thought it could have been where a meteorite plunged into the seafloor. It could have been some kind of animal burrow. It could have been something dropped off a ship. We weren't really sure. Collected some sample, a sample of sediment from it, and proceeded to find all of this little melted meteorite bits. So apparently, that little pit was caused by a meteorite coming down through the water, embedding itself in the seafloor, and mixing a bunch of little pieces in with the sediment. The ROV Falcor came through, collected samples here as well. About another year after the Nautilus visit, and also we collected samples with ROV. At the time, I was still patiently working my way through all these sediment samples one at a time. Didn't have quite as clear a picture as we do now. That this site is very promising to find a large meteorite at. But yeah, the Nautilus collected samples, the Falcor has collected samples, and now we are back for the third time.
That's good to point.
And we came back specifically with ROV specifically set to dig, as you see now, to dig into the seafloor and try to get this one, dig down to where there's evidence indicates there's a meteorite below this particular spot. So that's kind of my long rambling story of why we are here.
Mark, were you on ship for the first time we came out here?
Yes.
Nice.
Hey, Mark, hold on just a second.
Yeah.
Betsy, are you listening in on SPL? And can you talk on SPL for us? Betsy, are you out there?
Who are you talking
I
to?
am here. Can you hear me? Can you hear me?
Yes, we can hear you. Go ahead and talk on SPL now if you like.
Wonderful. Well, good morning, everybody. My name is Dr. Betsy Pugel. I'm with the NASA Goddard Space Flight Center. I'm very happy to join you once again. I think, Mark, maybe third time's a charm in finding this meteorite. So glad to hear that the comms are working. Thank you to Ed and everybody for their assistance.
Yay, glad to have you here. Betsy is not quite as rambling and as incoherent as I am. She can probably tell a better tale than I.
Well, you're hardly rambling and incoherent, Mark. I think that was a great story, great summary of the efforts that everybody's put into doing this recovery. And I just want to add, your diligence in sorting through grain by grain, what with a feather and underneath a microscope to find all those wonderful finds. It's incredible, the amount of painstaking patience that you've had to kind of go through.
Yeah, I don't have a life. Makes it easy. No,
Yeah.
honestly, like you said, I sat there.
I'm ready for Zoom if you are.
And looking through all this material. I just sat with a microscope and a.
It looks like it's going in. Go ahead and zoom
All
in
right,
there.
you ready for the Zoom?
Yeah,
I had to
go
get
ahead.
rid of SPL. I did too much talking. You ready for Zoom?
Yes, please. That's good. Bring it over here a little bit. Looks like she's doing.
Oh, looks sandy. That's good.
Thank
I'm zooming out a bit. Just keep you in frame.
you. Oh, we lose Viz in the bottom of his pit. I'll go a little higher.
Run out a little more.
Roger.
You want to go wide again? Oh,
Coming out wide.
Sure.
You want to come wider? I think I've got more. Plenty
That's
more.
fine there.
Okay.
I feel like if I push it and smear it a little bit, that somehow gets a little bit more flow in it. So ruins the biz.
is Mark still with us?
Yeah, sorry, Mark.
Yes,
All
I am.
yours.
It's Kim. I'm wondering if there's some other way to detect a meteorite or fragments in the sediment, like maybe there's sufficient magnetic anomaly that would show up on like a magnetometer or something.
Quite possibly. If you had a magnetometer and could get it close enough, we talked about this and decided that it probably could be done. It would require a lot of time spent searching back and forth, trying to look for the magnetic anomalies. Which with an ROV, it'll pretty time intensive activity. It's hard enough on land. Part of the reason why we're here because we already have a good indications that there's a meteorite here and we don't have to do any searching. So that's less time spent searching and more time spent with this exciting hole digging behavior.
It's a very expensive and ineffective, at least so far, crab trap.
Betsy or Ralph, are you on SPL? And if so, can you talk to us?
Yes, I'm here on SPL.
Okay, Betsy.
This is Betsy.
Thank you. Ralph, are you there? Still trying to make a
Yep,
connection.
this is Ralph. I hope
There's
you can hear
Ralph.
me.
Okay, very good. Just double checking. We'll let you do what you like to do. Feel free to jump in.
This is great. This is like a whole new level of COVID flexibility and work from home. We are working from home, several time zones away, and helping out with a dig a hole in the bottom of the ocean. This is kind of new for me, that's for sure. Hey, Ralph, could you introduce yourself? I mean, I could do it, but I'd probably embarrass you.
Yeah, go ahead and
Sure.
cycle it again.
I'm a planetary materials guy, a professor at Case Western Reserve University in beautiful Cleveland, Ohio, and kind of hovering over Mark's shoulder to make sure he doesn't think a crab is actually a meteorite.
Awesome. Thanks, Kim.
That's good. Somebody's got to do that. So Ralph's being modest. Ralph ran the Antarctic search for meteorites for some. Was it 30 years or was it longer than 30 years?
Wow.
I'm still the PI, but I've retired to wise old sage status, which means I just tell people what to do and tell them they're doing a good job. So this virtual fieldwork thing is a natural for me. But my first trip to Antarctica was 32 years ago, and I've done 24 summers.
For those who don't know, the Antarctic Search for Meteorites, or ANSMET, travels to Antarctica every year, and they have a team that spends upwards of 6 weeks living out on the Antarctic ice in tents, and either walking, doing searching on foot or searching on snowmobiles to find meteorites. And they basically go to ends of the earth that are remote enough that the only rocks you find are the ones that fell there. And these Ralph's collected tens of thousands of meteorites at this point.
I think we're at 23,500 right now.
Wow, that's incredible.
Yeah.
Unfortunately, COVID has killed most of the science programs in Antarctica this coming austral summer. So this is all I get.
They've found the ANSMET and the World Meteorite Collection in general they include pieces of asteroids, other planets. We have samples of Mars. So they have quite a few samples of Mars at this point. Samples of the moon, and
Go ahead.
These are samples that are studied all over the world by researchers all over the world about every manner you can imagine.
Thank you. The hole is quite poor, isn't it? Yeah, you want to come a little wide there, Al.
I'm going to try cycling that again.
Yeah, go ahead. Try giving this guy
I don't know why that does anything, but it seems to.
Slightly off topic, but Betsy, not sure if you're still there, but I met you this past fall at AGU. You were at the Deep Submergence meeting talking about the meteorite search on Falkor, and then we hung out a bit at Lily Simonson's gallery.
Go ahead and push in there a bit, Al, please. That's great, thanks.
I remember going to conferences.
Remember that? I remember going to conferences. I remember going out to dinner too. That was nice.
Yeah.
Meanwhile, I have an unexplained urge to go home and clean my house.
I'm wondering if meteorites fall on Antarctica. Are they sitting on the surface? Are they buried in the ice? I think like they'd be maybe still warm when they got there.
That's a pretty common question, and the answer is that by the time they hit the surface, they've fallen down to about terminal velocity. So they don't really bury themselves. And a big part of my job is finding the places in Antarctica where the action of the winds and keep the snow and ice clear of snow. And then these areas also have very little glacial movement. So the combination of loss of snow and ice from the wind and evaporation superimposed on a piece of glacial ice where there's very little horizontal movement creates a surface where the meteorites can pile up over tens of thousands or hundreds of thousands or maybe even millions of years. So they're not falling very often, but if you lay out a clean white tablecloth several kilometers across and just let it sit there for a million years, you start to find some interesting rocks.
Would any of those, like given that, I have a mental picture of contrast between presumably dark material on a white background. Is there any, can you see those from the air or from space?
You're a little broken up. Could you try that again?
I'm thinking presumably contrasting material on a white background, could that material be seen from the air or even from satellite?
That's another common question, and the answer is sure, you could see it. But most of the areas we hunt for meteorites now have terrestrial rock mixed in. And so far, there's no way to tell a meteorite from a terrestrial rock in any easy way from the air. So it still requires boots on the ground. It requires the human eye, brain system to kind of quickly look at something and say, that's not from around here. And, you know, I get asked probably 20 times a year by fancy drone makers if they could build us a drone, but they're mistaking the need to move around for the need to have a brain. And humans are cheap compared to drones in terms of moving them around. All they need is some hot chocolate.
Or sorry, Al, we get them a little wide. Thank you.
I'm always cheered to hear any observation that we're not totally redundant yet as boots on the ground.
Don't get me wrong, I'd love to have a robot make my hot cocoa.
So what are some of the ways that you can tell apart a terrestrial rock from a meteorite?
The first order feature of a meteorite is that when it plummets through the Earth's atmosphere, it's going so fast that a big part of its energy is converted to friction right on its surface. So even though the meteorite, which is basically a rock, is sitting in space at 17 degrees above absolute zero, the outer millimeter or so melts and vaporizes, and that's the trail you see when a meteor goes through the atmosphere. The little specks and
There's some
melt
wider
droplets and stuff.
Is that a little octopus or a cuttlefish at the lower left?
That
The
was,
hole?
yeah, we can, we'll see it
Right.
momentarily. Gonna disturb his home. All right, go ahead and push on in there a bit, Al.
Nice.
I'm having fun
All
watching
good.
the little
Yeah.
crabs swim around.
Just wishing that the venturi would.
Yeah, that looks like a little octopus there, although treading away
Oh.
from the crab
It's
now.
a little squid.
It's a
Excuse
squid?
you, crab.
It's a big test of our crab trap. Oh, failed
It's a
again.
Dungeness crab, too. They're delicious.
Look at this guy. Going nuts.
I'll try cycling that again.
Anyway, just to quickly finish the story, meteorites have this burnt outer coating we call fusion crust. And it's black and a little bit glassy. And it's very diagnostic because there really aren't that many terrestrial processes that can do that.
Yeah.
It's just kind of mesmerizing. It's a little like watching the Zamboni.
Yeah.
You know, it's kind of interesting in this area. We don't seem to be hitting an area that has, you know, lots of those river pebbles like we saw before. We're at a certain depth, right? There were pebbles beneath all the snow, and unless I fell asleep and missed something.
No, I wish there were. This is the center of the hole. There seems to be sandy. The great place to lose a meteorite in.
It reminds me of all those popular pressure washing videos on YouTube.
Yes, right. The kind of the zen of pressure washing.
Very engrossing material.
We have a 3D printer here, and you get the same effect. My son and I will just end up sitting there watching it. You can't really watch the thing grow while you're watching it. Just the, I don't know, same effect. Like, ooh, look at the moving parts.
We have one on the ship now too, and it's similar, and the noise is very comforting. It's like a bird chirping in the background.
Science nerds are easily amused, clearly.
So we got any more flow going on? Yeah. I'm just trying to check if there's flow. Do you think we should try recycling this guy again? No. Yeah. That was a good point. Yeah. Thanks, Al. Getting there. Sorry about that. Go ahead and push them back in there a bit, Al. We need to tighten the hose clamp on the dredge there. The schnozzle. Al, you want to push on in a little bit there, please? Thank you.
So this event showed up on weather radar. You could see the falling meteorites, and it showed up on weather radars from NOAA's NEXRAD system, which covers most of the contiguous 48 states and parts of Hawaii, Alaska, a few other places. In the approximately 30 years that the system's been running, there's been more than 24 meteorite falls that show up on radar, and people have actually recovered meteorites from them. There's a crab in that hole again. So yeah, over 24 meteorite falls, and it's also revealed about another 15 that show up on radar. Really good candidates for. They certainly look like meteorite falls. All of them correlate to somebody, eyewitnesses seeing a large fireball in the sky. So we're talking, easily more than one meteorite fall per year in the U.S. in the range of the NEXRAD system. And when you have a meteorite fall, there's at least one that produces enough meteorites to be found. They are always difficult to find meteorites, even when they're on land, even when they are, on relatively clear ground. It doesn't take much in the way of rough terrain to completely hide or bury a meteorite fall. You figure any meteorites fall into a swamp, they're gone. Anything that falls into rugged terrain, or even just where nobody happens to see them fall, those meteorite falls are all.
Wide, please, Al. Thank you. Full wide, please. You want to go full wide there, Al, please? Thanks. I'm just gonna get the schmutz out of the nozzle.
Don't want to cycle it?
Yeah. Thank you. All those bits.
Occurs to me I should probably run around and check the comps. Okay with that?
Yeah, that's good. All right, Al. You want to push back on in there, please? Thank you.
So I was talking about recovering meteorites. On land, you find meteorites. Basically, there is no magic bullet. The best detector for finding meteorites is a human eyeball. On a human that has some training in what a meteorite looks like and what terrestrial, as opposed to just terrestrial rocks. And kind of as a rule of thumb, a meteorite fall, you can on a really nice meteorite fall with lots of meteorites and really clear ground for searching, you can basically hope for finding a meteorite for every day's worth of walking around that you do. So it's not easy. There's not meteorite falls don't tend to drop. There's this image that they produce this shower of stones that scatter themselves across everywhere you look, and that's usually not the case. More likely, it's maybe 100 findable rocks. It's a complete arbitrary number, honestly, because it's hard to tell how many over many square kilometers of ground. And so, point I'm trying to make is that finding meteorites takes a lot of work and is difficult on land. You translate that to doing that in the ocean, and it's even more difficult, even more work. The reason why we're at this particular spot is because we have pretty good confidence that there is a meteorite at this spot. This was the site of a little impact pit in the seafloor that Nautilus came across the first time it was here back in 2018. For those of you who didn't hear me talking about this earlier, we basically collected a sample out of that little pit, and it turns out to have a pretty high proportion of little tiny melted meteorite bits. So that's just kind of why we're here and why we're on our third try at finding meteorites. It's not simple on land, and takes extra effort at sea.
I'm thinking, I don't know if it's appropriate, but I'm thinking maybe some analog to hunting for dinosaur bones. And it occurs to me right away that you might have private individuals, treasure hunters, if you forgive the expression, going out and looking for meteorites. Are they saleable? Are they valuable? Can you buy one on the internet?
So eBay has a section on that is all minerals and meteorites, which kind of answers it. You can go there now, and there's probably thousands of meteorites for sale on there. NASA's collections are not for sale. We don't ever sell them. They're only for research purposes. But yeah, there's definitely folks who go out and search for these things for that reason.
So I presume that's just as annoying for you as it is for paleontologists to see like dinosaur bones for sale?
It's a well. So there's couple of there's like two sides to it. So there are people who go out and find meteorites solely to sell them, but the flip side of that is they go out and find meteorites, and your average scientist doesn't have the time to go spend 6 weeks or a month or whatever it takes at a site trying to find meteorites. It ends up falling to folks who do that. So yeah, they get sold, but they also wind up in collections, which includes like museums. They wind up in research collections. It's not a cut and dried thing. Yes, people go out and hunt for them to sell them, but the flip side of that is that every one they found is one that would probably end up rusting away somewhere otherwise.
From my understanding, there is special care that needs to be done to make sure the meteorite doesn't kind of decompose. I guess that's the wrong word for it, but can you elaborate on that a little bit?
Sure. So that is, in a word, curation. Yes, there's meteorites require special care. When a meteorite falls on Earth, it's seeing probably more oxygen than it's ever seen in its previous 4.5 billion years of history, and probably more water than it's seen in that time. Even if you put it under controlled conditions, there will be what we call terrestrial alteration, changes due to environment. And so there's like two parts of that. One, anybody doing research on meteorites has to accept that that's going to be there, and that's just and it becomes part of their research techniques. You have to account for any terrestrial alteration in the meteorite sample and account for it and identify what is native to the rock and what was added to it in its time on Earth. And most of these, from any collection, if they landed on Earth, then they very well may have been rained on, or all of them have microbes. They're exposed to terrestrial microbes. There's all manner of alteration that occurs. So there's kind of the second aspect of that. The first part is analytical. Second aspect of that is curation, and that's what you're asking there. Basically, how do you care for these? And short answer is you keep them dry, you keep them in controlled conditions, and then you carefully document what those conditions are so that the people doing the research know what to expect in terms of terrestrial alteration. That said, a lot of meteorites have been altered quite a bit, and that's just the nature of the thing. These things, they fall to Earth, and we find them after some period of time, and in that some period of time, they've had a chance to be altered. They're still useful. At this point, we've gotten pretty good at doing that analytical part where you identify what in the rock has been changed since it landed on Earth. So, the meteorite we're looking for here, it's obviously sitting under 90 meters of salt water and has been there for 2 years. It will be altered, but that's okay. We that going into it, and we can identify what is changed on Earth. Kind of ignore that part and work on the parts of the meteorite that actually came from space. A lot of the meteorites found are come from the Sahara, the nomads who travel back and forth across the Sahara every year have figured out that if they keep an eye out for the funny looking black rocks that are revealed as the sand shift, or just happen to be, wherever they find them, that they can, that those are valuable and they should grab them. And there's quite a large number of meteorites come out of Africa for that, the Sahara region. There's a whole class of meteorites a large number of meteorites that are classified as the Northwest Africa meteorites. I think they're up to over 12,000 individual ones at this point. Those are all altered. They've sat out in the sun. They get cold at night, hot during the day. They've been there for, from periods ranging from recently fallen to upwards of hundreds of thousands of years. Depends on how well they're preserved. So, long answer, but yes, they need to be cared for, and you need to be careful in doing the measurements, whatever measurement it is, to make sure that terrestrial alteration is accounted for. People who work on meteorites, by and large, have become quite good at that.
In terms of alteration, like presumably there's meteorites on the moon. If you were able to recover one from the moon, would that? I'm thinking that would be have particular value.
Hold on just a second, I'll answer.
Yeah, it's quite slow, right? Very good.
Okay, sorry, I had to step away for a minute. Meteorites on the moon. Yes, there are meteorites on the moon. There was one that I'm certain about. I think there is another one or two that have been identified in the samples that were brought back by Apollo astronauts. There was a meteorite found in amongst the moon rocks. It's called the bench crater chondrite from the site on the moon where it was collected. Even that's altered. It's just altered in a different way. So on the moon, there's no atmosphere, so there's no, it's not going to alter any meteorites there from like atmospheric water or oxygen. But there's also no atmosphere, so there's nothing to slow it down on the way into the moon. So anything striking the moon moves much, much faster than anything falling to Earth. On Earth, the atmosphere destroys the friction of hitting the atmosphere, the bright fireball you see with a infalling meteorite. That'll destroy all of the meteorite, or do like 90%. But the surviving pieces are now slowed down to falling speed, and they will strike the ground without, if they survive that, hitting the ground probably isn't going to do anything more than add some chips to them. Anything hitting the moon is going to be moving, I believe the minimum speed is like 8 kilometers per second, or maybe it's 6. Whatever it is, it's very, very high. And so the bench crater chondrite is shocked. and anything else that hits the moon is going to be really badly shocked. So they're there. It's just a matter of pick your alteration. You still have to account for it. The interesting thing, there was not too long ago, there was a report of some scientists looking at Apollo samples think that they found a small piece of the Earth in the lunar samples. There was basically an Earth meteorite kicked off of the Earth's surface by an impact, which then wound up slamming into the moon and getting preserved there. So it's something that's probably very old, but it's been melted and shocked and pretty badly beat up. Again, pick your alteration. Everything gets altered. The least.
Rust never sleeps.
Sorry, go ahead. Yeah, rust never sleeps. The least altered materials are stuff that we get from sample return missions. When we send a spacecraft off to another body to go collect some pieces and bring it back, because those have not come barreling through the atmosphere at high speed, and they immediately go into curation and are cared for. The Apollo moon rocks, for example, are kept under nitrogen here at Johnson Space Center, and were collected carefully, and we know the location where all of them were collected and everything else. There's still some alteration because that process is not completely contaminant free, although it's a lot less than what you get from meteorites. But meteorites, you also don't have to build the spacecraft. They do you the favor of coming to you. Hopefully they come to us the favor of coming to that little pit in the seafloor, and we're going to get it out of there.
I remember reading, Mark, in the popular press that there's some speculation that some meteorites that have been found are actually from Mars. Is that a thing?
That's a thing. We have at this point, it's over 150 separate meteorites, named meteorites from Mars. They actually amount to about a fifth of a metric ton of material from Mars. Which, they're meteorites. They are the upside is it's material from Mars. We can take it in the laboratory and study it atom by atom, mineralogy, composition, isotopic composition, everything else you want to do, organics, etc. Excuse me. One of the downsides there is we don't know exactly where on Mars. You basically, Martian meteorite comes from Mars. That's about as well as we can constrain it. We can try to narrow that down based on data from orbiters and landers and such, but yeah, they're extremely valuable for understanding Mars, because otherwise we don't have any pieces of it at all. But they have their limitations like anything else. The question that often comes up with these Martian meteorites is, well, how do you know they're from Mars? Which is a good question. And it's a fun story. They're basically, all right, let me tell the story. So one of the first Martian meteorites ever thought to possibly come from Mars It was one that contained little pockets, centimeter size, millimeter size pockets of glass in the rock. And there's spots where when this thing was kicked free, you figure that you had to have an impact strong enough to kick rocks completely off of Mars and into space. So it's a pretty big impact, and it shocked this rock to the point where parts of it were turned to glass. And there was a researcher, and the name is escaping me. I don't know it. I can't think of it. I apologize. But this guy was studying. Sorry?
Don Bogart was a real key player.
That's it. Thank you. Don Bogart was studying the glass for different purposes entirely. And one of the things his measurement turned up was the amount of noble gases that were in this glass. And the noble gases got there from trapped Martian atmosphere. And they were able to tell that because I think it was Don Bogart was working on the Viking mission, Viking landers on Mars, and basically looked at the composition, the amounts of the noble gases, and said, yeah, that kind of looks familiar, and went to the Viking landers' measurement of the noble gases in the Martian atmosphere and found that they were a match. The amount of argon, xenon, helium in the little pockets of glass was the same as what they saw measured in the Martian atmosphere by the Viking landers. So what had happened was this rock was absolutely pummeled and kicked clean off the planet, and part of it was melted, but it was melted while it was still in the Martian atmosphere, and it trapped some of that Martian atmosphere in the glass. And we were able to show that this thing did come from Mars, the place where that atmosphere was.
Real quick, science on the beach.
Sure.
You guys want to check out this hole and see how much wider, deeper you want this? So we'll zoom on in, just clearing my tubes. Go ahead and push on in there, Al. All right, that's great. So do you guys want it wider, deeper, as is, or what you guys thinking?
Deeper is better, but it's a lot wider than it was last time we used the magnet. Would you be interested in taking the magnet to it and seeing if we can get anything stuck to it? Either keep excavating, keep trying to make it deeper, or stick the magnet in there, and keep excavating. This is going to be our iteration as long as we have time. We're not going to go anywhere else.
Roger, understood. So is there a preference as to what you prefer?
Yeah, can we do the magnet?
Yeah, sure.
Okay.
Sounds good. Go ahead and come on full wide there, please, Al. Oh, thank you. That's why the button wasn't going.
Tilt tray up?
Yeah. Oh, I think I just did the starboard actually.
So earlier, the hole was big enough to put the magnet in there. It was basically, it was 1.5 magnets wide or so. And put it in the hole, actuated the little arm, and actually not much happened.